Hello class, in this video we are going to look at the quantum atomic model. So this is just a more advanced look at Bohr's model. In Bohr's model we had these orbits like this. That's what he's saying here, that we have this orbit, so it's almost two-dimensional. Now we know today they're more three-dimensional and we call these orbitals. So instead of it traveling in this one direction here, we can have electrons filling up these spaces, this orbital space. So let's look at a picture of these different orbitals. So this may be kind of weird for you to look at right now, but let me just try to explain. The darker regions is the higher probability where the electron could be. The electron's going to be in different areas, and the darker the area is, the more time spent by those electrons. And we can see that they make these different shapes, and these shapes are what we call orbitals. So here's a quick definition. An orbital is a 3D region around the nucleus where the electron is found. And here's two different orbital shapes. There's more than just these two shapes. We're going to look at them all today, but this is two basic ones. S orbital here is just a sphere shape. And then we have the p orbital that's more like a dumbbell shape. It's important that we remember that these orbitals aren't physical objects that you can touch. This is just really a region where the electron is restricted to. Kind of like borders on a map. They're not physical things, they're just marking out a region of space. And that's all that these orbitals are doing. So what we already know is that atoms have different energy levels, or shells, and we symbolize this by N. So N equals 1 is the first energy level, N equals 2, second energy level, and so forth. What we now are learning is that these shells are then divided into sub-levels, or sub-shells, which are labeled using the letters S, P, D, F, G, H. So each energy level is then divided into sub-levels, and they have these different sub-levels. One thing that is really clever is that each shell has its the same number of subshells as its shell number. So what does this mean? If shell 3, if we're looking at energy level 3, it has 3 subshells or sublevels, S, P, and D. If we were looking at 2, it would just be energy level 2 would just have S and P. Energy level 1 would only have S. Energy level 4 would have S, P, D, and F for the subshells. So the energy levels are divided into subshells, and then the subshells are divided into the orbitals, the 3D regions of space. And there's one s orbital, there are 3 p orbitals, there's 5 d orbitals, and 7 f orbitals. And remember, the orbitals are just those different shapes. So there's only one shape for the S, there's 3 for the P, 5 for the D, and 7 for the F. So if we could take a look at some, and I would draw this as well in your notes, that this is the S orbital, and it's just this sphere, and there's only one shape. P, it has pretty much the same shape, just in different orientations. This is the P going in the X direction, P in the Z, and then P and the Y, and these are the different ones, and all 3 of these together make up the P subshell. The S orbital makes up the S subshell as well. So if we put all 3 of these P's together, we will have a P subshell, and it looks like this. So this is a complete P subshell here. The D's, now this is not something that I want you to draw, this is just something that we can take a look at. Here's the 5 D orbitals here. So we have 5 d orbitals, and we can see that they kind of get more and more complex. If we try to put all these together, we get something like this. Not something that we're going to need to draw. Okay, so we need to know that each orbital can hold a total of 2 electrons, as long as they have different spins. And we'll talk more about the spins when we talk about orbital notation. But just this means that the S has one orbital, and the whole subshell then can hold 2 electrons. P has 3 orbitals, each orbital holding 2 electrons. That's how we get 6 electrons in the P. D subshell has 5 orbitals, each one holding 2. That's how we get 10. And the F then would have 14 electrons. But we're going to usually use just these 3 different subshells here. So now we have each energy level kind of divided up. So energy level 1 or shell 1 has subshells just S with 1 orbital and holding 2 electrons. Energy level 2 or shell 2 has 2 subshells, S and P, which is different from this S. This is for energy level 1. So it has S and P. S we know has 1 orbital, P 3, holding a total of 8 electrons, 2 in the S orbital and 6 here in the 3p orbitals, giving us 8. And this goes on for the 3rd and the 4th energy levels. This information here is going to be very, very useful in our next video when we start talking about electron configuration and the orbital notation. So please come with questions to class, and I'll see you then.